Guys, today we are going to solve a Leetcode problem. It's 1349. It's a hard problem and it's posted by Rahul, right? So as always, we are going to explain this problem by introducing the example here. So in the input, we are going to have a two-dimensional array, and this array tells us there are some seeds, right? And if the character is pound key, it means that the seat cannot be used, right? And if it is a dot, it means a student can sit there, right? And the output put here is how many students we can put into the classroom, right? So we need to get the maximum number, right? So in this case, the maximum number of students we can fill in the map is 4, right? Why cannot these two seats be occupied by students? Because if we place a student here, this student can see the um, students before him, upper right, upper left, and left and right, right? So if we put a student at somewhere, it's upper left, upper right, left and right cannot be sit by students anymore. So that's a rule in the classroom, right? So how do we calculate the number of um, the maximum number of students? So let's first take a look at the scale of this problem. So there are at most m 8 rows and 8 columns. It's quite a small number, right? So as soon as we find out the scale of the problem is small, we need to reflect that we can use binary compression here. So and it is to calculate the maximum. So we can reflect that we also need to use um, dynamic programming, right? So to use the dynamic programming, what is the formula here? So here is the formula. Fij means for the first I row, if the state is j, what is the maximum number of students? So what is the state here? State j means if let's say there is one row, the first row, right? And the initial state is 0, right? So 50 in binary format means 0, right? So if this seat is occupied, it means like this, right? And this is a binary format. So let's translate it into decimal. That is 0, 1, 0, 0, 0, right? So in decimal it's 8, right? And what about these two seats are occupied? It means in binary it's like this, right? So 0, 1, 0, right? Like this. So it's 18. So we miss a 0 here. It's not 8, right? Actually, it's 16. So for each row, we can have a state because for each seat is either occupied by students, which is 1, or not occupied by a student, which is 0. So for each row, we can always get a number that is less than um, 2 to the power of m in decimal format, right? So m here is as large as 8, so it's not so big, less than 1000, right? It's still a small number. So if the ith row state is j, so j is a decimal number which we can transform it into a binary form, and that number can represent this row's state, right? So let's move on. What is tk here? So tk here means for the ith row, for example, for the first row, the state is k. Let's say its state is currently like this, right? So one of the seat is occupied, right? And we can do something to this state, right? What we can do, we can place another student uh, into the row, right? For example, we can place a student here. So that is the transition of our states, right? So initially, the initial state is all 0, and we can iterate all of the options we have. We only have n options, so at most 8 options, right? So we either put a student at the first seat, or the second seat, or the third seat, um, or the 8th seat, right? So we at most has 8 options, so we can just iterate each of them. And in that way, we can deduct all the other states we can have from the initial state, right? And we can be sure that if state j is bigger, the number of state j is bigger than I, um, state j is always transformed from a state that is less than j, right? So we can, in this way, we can deduct all of those states from the initial states, right? So here is the detail of the transition between two states. So in the ith row, we choose to place a student at D. So in our example, we choose a student D here, right? And the new state, uh, this is the old state, right? And the new state is K do the OR operator to one move left D digits, right? So D here is 2. So we move 1 to its left, right? So we get a number like this, and we do a OR operation so that we get a number like this, right? So this is the new state. And if the new state's uh, original value is lesser than the new value, we can replace it using the bigger one, right? So this guy is the initial state plus 1, right? Because um, TK is the maximum number of students we can get from this state. And now we add a new student into the state. So the counter of students is increased by 1, right? So that is the way we get the transition between two states. And um, to uh, to be cautious, so we had to make sure we put a student at a good place, right? How do we ensure of that? So first, we need to make sure that for the current state, there, there is no student already occupied this place, right? For example, if the initial state is like this, we cannot put another student at this place anymore because this place is already occupied, right? So we need to check it if the place itself is not occupied, right? And we need to also check the to the left of that place is not occupied as well because of the rule, right? And also to the right, also to the upper left, upper right. So how do we check upper left and upper right? Here is where we need to use Fij, right? So we need to, in order to calculate Fij, we can be sure that we already calculate Fi minus 1 j, right? So we are going to have a for loop for I. So I minus 1 is always calculated before Fi, right? So if these values are already occupied, so we can iterate each of the values. So let's say we are going to calculate F2, right? We are going to calculate all of the F2 values in this row, right? That means we already calculate F1 values in the first row, right? So we are going to iterate all of the F1 states. So from 0 to 2 to the power of n. We are going to iterate all of them. And after we get the number, get the state of the first row, when we calculate the second row, we can be sure that the um, the state of the row above them, and we can check if the upper left and the upper right is occupied by students, right? So this part can make use of the state of the upper row, right? So I guess that's it. We can now take a look at the code here. So here is the code. So we initialize the f. So this is n rows, right? And this is our 2 to the power of n states, right? We get n and n. Then we set the initial value to -1. So -1 means we cannot get this kind of state, right? For example, if for the first row, each of the seeds are bad, right? So you cannot get 1, 1, 1 in binary form for the first row, right? Because all the seeds are bad. So that means F1 or equal to -1, right? If it equals to 0, that means you cannot put any students in that state, right? It's essentially the same thing. 0 and -1 is essentially the same thing. So the initial state is that if 0, 0 equals to 0, right? If we take the first the row before the first row, and for the state 0, the maximum student we can put in is 0, right? So that makes sense. And we are going to start from the first row to the last row. And we are going to iterate all of the states for the row before I, right? So J is the state of the upper row, right? Remember that. J is the state of the upper row. And now we initialize the array of T and make them all 0 initially. And for the state 0, its value is fi minus 1j. So why is that? So this guy is the upper row with j as the state, right? And T0 means we don't put any student in this row, right? So if we don't put any student in the current row and the upper row's state is j, then it means we can just directly put the maximum number of students of the state j into the T0, right? Because T0 means we don't put any student in the current row, right? And if I0 equals to maximum of these two numbers, so we are going to use T0 to update Fi0, right? So I guess that's also pretty obvious. And let's move on. So K here is the in the current ith row, the state is K. So it's the current row's state, right? And the first iteration is that we use the initial state. We start from the initial state and we iterate all of our options here. So we can put a student at the first place, at the second place, all the way to the m place, right? So we are going to iterate all of our options to add one more student. And because the current state is k, right? So we need to make sure that the option we do not choose the option that the seat is already occupied by K, right? If K is like this, and we want to put another student at this place, we are going to have a false here, right? So this part make sure of that, and this part is make sure of that its left um, seat is also not occupied. And this part is make sure of that the right seat is not occupied. And this part is deal with J here, right? So do you still remember that the J means the state of the upper row? So here is where we check the upper left is not occupied. And here is where we check the upper right is not occupied. And they both use J here, right? So when we need to check the current row, we use K, right? And when we need to check the upper row, we use J, right? So these two states are very important, J and K. And if all these conditions are satisfied, it means we can actually put a student at that place. And we can calculate the next state. And we are going to update the state's value, right? We always choose the bigger value. And in the end, we're going to choose the maximum value of for the first n rows, right? So, and return the answer. So I guess that's it. Thank you for watching.